What is involute? The definition of involute is if a straight line is rolled around a circle without slipping or sliding, points on the line will trace out involutes. The another definition of the involute is it is a curve traced out by a point on a tight string unwound or wound from or on the surface of the circle or polygon. Suppose this is my circle and here this is one straight line, or you can say one string is here. Now by pick up this end at fix at the circle circumference, and if we round a string around a surface of the circle, so this end point goes in different points like this, and after one revolution suppose it is here. So if you concentrate on the end point of the string and trace all the points, you will get this type of curve. This is known as involute of circle. Instead of circle, suppose we have a polygon, square, pentagon, hexagon, and on that surface if you rotate or wound the string, keeping string will be tight, the loci of the end of the string trace the involute of polygons. What is the application of involute curve? So it is used to design the gear tooth profile. So in particular this gear, this is one tooth, and on the periphery of this tooth or the profile of the tooth is in curve form. So it is actually involute of circle. What is involute of line? So for understand this curve, we are going to take one example. Draw an involute of line of 10 mm or 2.5 tons. So we have given one line 10 mm long, and we have to unwound the string from that particular line, and our unwounded ton is 2.5. So draw horizontal line. On that line we mark a 10 mm long line AB. Now P0 is the end of string. Actually string is in wounded condition and we have to unwound the string from this line. So the end of the string is P0. When we unwound the string half turn, we will get the semicircle like this. So the semicircle is of radius 10 and center of this semicircle is B. So this is the involute of line for half revolutions. If we extend P1 end for another half revolutions, so for that we have to take A center 20 mm radius and draw semicircle. This is P2. So up to this involute is known as involute of line for one revolution. Then extend by taking B center 30 mm radius, draw semicircle. Then A center 40 mm radius, another semicircle. And B center 50 mm radius, another semicircle. So this curve is known as involute of line for 2.5 revolutions or convolution. So another example for polygon here, involute of 25 mm square size. A string is kept tight while unwinding it from a square prism which is resting with its base on HP. Trace the path of end point of string If 100 mm long string can be unwound in one turn, name the path traced by the end point of the string. So here actually we have given one square and we have to unwound the string 100 mm. So for one turn and the open string is 100 mm, then the square must be 25 mm. So draw one square of 25 mm side, give the name of the corner 1, 2, 3, 4. Now P0 is the end of the string. We have to unwound it for one turn. So for that we have to draw a tangent from 1, means extend 2 1 line, extend 3 2 line, extend 4 3 line and 1 4 line. Now when we open the thread from P0 up to tangent T1, we will get one quarter circle of radius 25 mm. So this arc is drawn with the use of taking one center 25 mm radius and draw arc from P0 to P1. Now center 2 radius 50, draw arc from P1 to P2. 3 center 75 mm radius, draw arc from P2 to P3. And 4 center 4 P3 radius, draw arc from P3 to P4 by taking 100 mm radius. Unwounded string is 100 mm long. Now how to draw normal and tangent in any polygons? Select a point S on the involute, then join S to 3 because this arc is drawn with the use of radius 75 and center 3. So that's why we have to join S to 3. If our S is somewhere here, then we have to join that point to 4 because this arc has a center. And draw the perpendicular line to normal, which is known as tangent. So tangent and normal are always perpendicular. Okay. What is the name of this curve? The name of this curve is known as involute of square. Now another example of involute of circle. A string is wound round a circle of 30 mm radius. Draw the locus of end of the string for winding the string completely. String is kept tight while being wound. Draw the normal and tangent to the curve at any point. So given data is only radius of circle. Okay, so first of all we have to find out the circumference length of the circle. So 2 pi r is equal to 188.4 mm. So let us start to drawing. Draw first circle and divide into n number of equal parts. Here 8 equal parts. Draw horizontal line from bottom of the circle. This length must be circumference 2 pi r or by d. Divide this line also into 8 number of equal parts. Okay. Now this point is our end of the string and we want to wound this string around the surface of this circle by keeping string tight, and this end of the string is fixed at the bottom of the circle. For that we have to draw tangent from 1, tangent from 2, tangent from 3, 4, 5, 6, 7. Now when we wound the string from here P0 up to this line, so here suppose this is P1 point. So what is the distance between P0 and 1? This must be 1 to 8 distance, the distance between 1 and 8. So P1 is obtained by taking one center, here 1 8 distance radius and draw arc on this tangent 1 P1 to obtain P1. Similarly, how to obtain P2? So here 2 center, 2 8 radius, draw arc. 3 center, 3 8 radius to obtain P3. 4 center, 48 radius, draw arc to obtain P4. 5 center, 5 radius, draw arc to obtain P5. 6 center, 6, 8 radius, P6, and 7, 8 radius, 7 center for P7, and the end of the string is exactly P8 here. So up to this we have only the points on every tangents. So you have to draw a freehand curve which are passing from P0, P1, P2, P3, P4 up to P8. The arc must be smooth. This is involute of circle. Now how to draw the normal and tangent? So you have to select any point on the curve S, join S to center of the circle, then find out midpoint of SO line. Then from that midpoint you have to draw one semicircle by taking radius half of SO, and you have to draw the semicircle on right side. Now the semicircle intersect the circle at N. So join NS is normal and perpendicular to normal tangent. Okay, thank you very much.